DataMasters is the go-to place for data enthusiasts. We speak with data leaders from around the world about data, analytics, and the emerging technologies and techniques data-savvy organizations are tapping into to gain a competitive advantage. Our experts also share their opinions and perspectives about the hyped and overhyped industry trends we may all be geeking out over. Join the DataMasters podcast with your host, Anthony Dayton, Data Products General Manager at Tamr.
Welcome to another episode of DataMasters. Today's guest is Dean Abbott, founder and president of Abbott Analytics. Operating since March 1999, Abbott Analytics leads organizations through the process of applying and integrating leading-edge data mining and machine learning methods to marketing, research, and general business endeavors. Abbott Analytics has been dedicated to improving efficiency, ROI, and regulatory compliance through machine learning. Before founding Abbott Analytics, Dean worked as the chief data scientist of Wonderkind and chief data scientist and co-founder of Smarter HQ. Welcome, Dean.
It's a pleasure to be here. It's always fun to talk data, for all of us geeks out there.
Yes, and hopefully we can do a bit of that. So before we dig into data and analytics and machine learning, maybe share a little bit about the Abbott's, founding story, how you came into this business, having been doing it since 1999, that's a long time ago. So you have quite some history here.
Yeah, and the Abbott Analytics story started in 1999, as you indicated, but my story with analytics in general really began in the late 80s, 1987. And I've been doing essentially the same kind of analysis for, 35, 36 years now. Starting out of grad school, I was at the University of Virginia, found a temporary job with a company that was doing missile guidance. And I was in applied math and control systems, control theory. And I was interested in such arcane things like differential equations and stuff like that. And that's why controls worked. But the secret sauce to that company was using statistical learning to apply to optimize guidance commands. And that turned out to be the part that was really, really interesting. And several in that company started their own, at that time, machine learning or data mining companies back in the 90s. And I finally went independent in 1999 as a consultant after spending about a decade in mostly DoD consulting, or companies that were doing consulting. And since then, I've been working with companies, a wide range of companies since 99, just applying these techniques to solve business problems. And I'll tell you, I'm not a recipe-driven kind of guy. I love those kinds of problems that require more thinking and more connection with the business. So it's not like you can read a book on algorithms and say, oh, we'll use this algorithm here. You've got to connect it to what the business is trying to accomplish. And sometimes the simplest thing is just a statistical measure. Sometimes it's a machine learning model. Sometimes it's a whole infrastructure. So I've done this with a wide range of clients, everything from retail to DoD. I mentioned to you before that I built models for the Navy SEALs for years to try to predict who would make it through Hell Week. I've worked with the IRS for a decade or more, finding non-compliance on corporate tax returns, Revenue Canada to find how much does someone owe in tax. And I've done other wide range of behavioral marketing with, retail clients you would know and love, hopefully, to try to identify what would be the best content to put in an email, what's the best product to recommend for you, those kinds of questions. But they're all analytics driven at the bottom line.
Yeah, and I think that point about sometimes, rather than starting with the algorithm and thinking about how to apply it to a problem, starting with the problem and then thinking about what algorithms make sense. And sometimes a simpler technique is more applicable and more interpretable and sort of easier to apply to the problem. Given your history, I mean, in some sense, if you roll the clock back to 1999 and through to today, the analytics industry has changed a lot. The machine learning industry arguably has sort of come into its own. I mean, certainly statistics has been around a lot longer, but using computers to be able to calculate statistics extremely quickly and in great large quantities has changed a lot. But I'm curious in your perspective on how all of these things, in a sense, have changed since 1999 through today. Like, what are some of the bigger trends that you've seen over that time?
Yeah, that's a really interesting question. It's one I get a lot too, because I would say, except for a couple very notable exceptions, it's the same. And so when you go online, if you go to a website like Katie Nuggets or Carl, buddy of mine, friend and colleague Carl Rexer has a survey, a data science survey that he puts out every couple of years, the Rexer Analytics Data Science Survey. And one of the things they ask is, what algorithms do you use? Now, these are data science practitioners. What algorithms do you use to solve problems? Number one, linear regression or logistic regression. Number two, decision trees. Number three, and it's number three, k-means clustering. It's like the same story, and it's been like that for decades. However, the two biggest shifts, just mathematically, algorithmically, number one, starting around when I started, was the concept of ensemble modeling. And ensemble modeling means instead of just building one model, just build one regression or one tree, you actually build lots of them. And then all of these models have a slightly different take on identifying the patterns you're interested in. And then you combine those predictions into one final decision. And that approach has been tremendously effective at improving the accuracy. And if people listening to this are familiar with things like random forests or XGBoost, or those are examples of ensemble methods which have gained huge popularity in the space. So that's relatively new, late 90s, and it really took off in the last 10 years. The second big thing is the resurgence of neural networks in the form of deep learning. And it's really captured the mindset of the leading edge portion of the industry. And that's what things like ChatGPT is all about. It's really deep learning neural networks. And they're essentially the same kinds of neural networks, but they do a lot more than what I used to do in the 90s. But it's essentially the same kind of thing. The biggest difference, though, the reason why deep learning has taken off in the last 6, 8, 10 years is because of something else you mentioned, which is the computational power. So we can compute things that a generation ago, there's no way you could even dream of it. I used to build essentially deep learning networks, but I had to use, and this is the early 90s, for image processing. It was specialized hardware that cost tens of thousands of dollars for just one board that you would, and it would be what we may call SIMD processing. So single instruction, multiple data. So you'd do things in parallel and then stitch it together at the back end, all in hardware. And so deep learning is essentially doing that, but it's so much easier to do now. You've got the infrastructure is just phenomenal. And that means that people right out of school, right out of grad school or undergraduate school, can just leverage something in the cloud, build something huge, incredibly sophisticated, incredibly complex to solve very complex problems.
I would very much agree with that perspective. So if I were to try to summarize that, the techniques are largely the same, but what's changed in the last 10 years is the availability of highly scalable compute. And
yes,
I can speak to that personally. As an undergrad, I did a statistical modeling class, and I was trying to build a prediction model for oil prices. And each time I would build and test a model, it would take 15 to 20 minutes to build, calculate, and run. And so my ability to iterate models was constrained by my 286 processor on my compact sort of lunchbox style computer. It was the first all-nighter I pulled, and not because I was necessarily behind, but because simply getting through the models and testing and changing them was, just took a long time. And today you could probably do that entire exercise in, under a second. It was, just.
Oh, yeah. And the irony is now we're kind of back there in that way and another way that I think is really fascinating that I may touch on. But because of the complexity of some of the models that we can build now all of a sudden time matters again, because there's a period of time where time really didn't matter because you could do things so quickly. I kind of crashed at the San Diego University of California San Diego Supercomputer Center in the late 90s. There was a meeting of big data by these famous statisticians. And I asked if I could attend. I just wanted to listen because I was not in their league at all. One of the questions that was asked was, what's the largest data set you've worked with? How many rows? And for many of them, it was like 1,000 records, maybe 10,000 was big. And that day, millions was definitely possible, but that's kind of where people were capping things. Millions, maybe 10 millions if you had specialized hardware. And now like 1 million records, I mean, we don't even blink. I mean, that's like, yeah, whatever.
And to that point, so let's talk a little bit about the man of the hour, GPTs, large language models, neural nets. It very much has the public consciousness. I've said this before, but I think one of the smartest things OpenAI did was putting a chat interface on top of GPT. In fact, I don't know this for sure, since I don't know anyone on the inside, but I'm guessing that someone did that as a lark almost. And it's like, well, what if we put an interface to let people type chat messages back and forth to this? What would happen? And all of a sudden, it's taken off. So I'm curious, there's a lot of divergent opinion on large language models, on neural nets as it relates to language. Some people see it as wildly uninteresting, verbal diarrhea, I've heard it described as. Others think that, we are going to be seeing mass layoffs and the end of work as we turn over all of our daily work to a large language model. Where do you sit on the continuum?
Yeah, it's a really good question. And in the end, I don't know. I usually avoid predictions of where the technology is going because the times I have predicted, I've been so wildly wrong. But you're right that there is such a variety of opinions. I was speaking with a colleague the other day about the 10, 20, 30, 40% of the industry, like copywriting, that's just going to go away, in his opinion, because people just enter it into ChatGPT, tune the prompt properly, and you get this wonderfully written article. And I know there's news agencies that are doing that, and which is fascinating to me because I've tried it a lot. As you can imagine, I love tinkering with things. And oh, by the way, I think your supposition that it was a lark, I would not be surprised at either. In fact, I wouldn't be surprised if someone just said, how do we test this out? Let's just have a chat interface, and that'll just give us a better idea what it's doing, but it was genius because the natural language responses are, I think, part of what's capturing everyone. Now, this is not new. There are other language models that do this kind of thing. In fact, I used to, for fun, 10, 12 years ago, we used to go to this website to enter my name, and it would generate a random mathematics paper of 10 pages in length. And it was funny as anything because all the language looked like math, but it was garbage. I mean, this like ChatGPT is not garbage, but this is completely garbage, but it read very mathematically correct. In fact, they claimed that they submitted to some conferences and got their papers accepted, that kind of thing. So, but my point is that this is not new. What is new is for such a large language model that's so comprehensive and not so narrowly focused like math, is able to respond in cogent ways to any prompt you give it. It's really a phenomenal architecture, and it's a phenomenal approach. And remember, this is one model, and I'm using that not in a very specific way, but in a kind of a nefarious, no, not even nefarious, just kind of an abstract way. One model doing all this. So there's good and there's bad with it. I've used ChatGPT myself to generate Python code. Say, generate to do X, and it'll generate some Python code for me. It's not perfect. And really what it does for me is it takes me through that first draft. Or I'll say generate text. Like I just did this. My daughter's getting married in a month and a half, and I wrote up a bunch of narrative about her and her fiance. I said, generate a poem, a rhyming poem about them that I could use like as father of the bride. And it generated something for me. Now, I'll say it was horrible. I mean, that's not something I would ever read. It was correct. It had the correct information. It had rhyming patterns, but it's so lacked creativity. And I think that's what I'm trying to get at from a writing standpoint. My experience with it has been it's factually kind of interesting and plausible, but it doesn't contain style. I know you can generate, if you can prompt it properly, maybe you can get better style out of it. But the other part of it that is a little concerning to me is it will regurgitate or will spit out information that comes across as authoritative and correct that's completely wrong. And in the before we started recording, I told you the story that a friend of mine was asking about who invented PMML, and it said me, or I was in the group that created PMML, and I'm not. Now I've written about PMML, I've written about model deployment where I've mentioned PMML, so I think I was associated in the data somehow, but it was completely wrong. But if you just did that prompt and wrote a news story, you'd be completely wrong. So I don't trust it. That's my main point. I don't trust it to do anything without some kind of layer that's put on top of it to refine, tune, because it's not the same as a Google search. You know, a Google search is finding an actual written document that says what you were asking for. This is generating language probabilistically based upon what it's seen in the corpus of literature it's consumed, that's saying, oh, when you see this kind of concept, these kinds of things are associated with it, and then it formulates these concepts or these ideas, strings them together. So it's not quite at the point where it can be fully trusted. That stated, it is still a phenomenal achievement, and I will use it, but I will not use it blindly.
Yeah, I think this point about trust is a really interesting one. And the comparison to Google is obviously, I mean, certainly Google executives are spending a lot of time thinking about how to, respond to the threat. But one of the things that I think the Google search engine does in PageRank is create a sense of authority. So the theory being that a highly page-ranked article or page is more authoritative than a lower ranked page-ranked page. And which isn't to say that high-ranked pages on Google are true, but they're certainly more authoritative and more likely to be true. And then, of course, this begs the question, what is truth? And to your point about, this idea of saying things with confidence that are false, I'd say humans have a long history of this. Entire business school classes are, people get good grades in business school by saying things that are not true, but with authority.
Yes.
It's almost a core skill of a CEO is to be able to speak with authority about and make stuff up.
Yeah, so it behooves us, in interacting with humans, when we base on how much we believe what someone says on their authority or their trustworthiness in the past, and we, trust but verify. I guess it's one of those phrases people use. Say, yeah, there are very few people that'll just believe everything they say without, unflinchingly. I think one of the things that is going to be a challenge for ChatGPT in the future is the data that it's using is, of course, digital data. And so it doesn't have the same kind of common sense that we as humans have. So I don't think we should view it as a human replacement, because we gather information in a wide variety of ways, through our senses, through our experience that's not articulated in any particular way. And also our way of learning clearly is not the same as what ChatGPT is doing. Now, I'm not saying that ChatGPT should try to emulate human learning. I mean, just like it was a colossal failure to try to emulate how to fly based upon how birds do it, And we've seen all those movies of people trying to do that, and it just doesn't work. So we had to come up. We'd understand the basic physics, and then come up with another way to fly. And in terms of like a natural conversant engine, language engine, or knowledge engine, I think we definitely need a different model than just trying to emulate human, because we don't understand how people learn particularly well. There's some things we understand, of course, but that's not something that we've plumbed the depths to the degree that we can emulate that mathematically anyway.
Fair point. So you make this point that the input data to these generative models is really important. And my guess is, although I don't want to put words in your mouth, that you might have a general view that the quality of data in the enterprise, or the quality of data as an input to any of the work that you have done or are doing, is one of the more important elements of the success of the project. And to the prior conversation, we would improve the quality of ChatGPT if we fed it better data. If we fed it only ground truth, whatever that means, then by definition, it would only speak ground truth.
That's right.
So maybe speak for a moment more generally than ChatGPT, but this idea of the quality of input data as an important grounding truth in model building and model, solving problems with models.
Yeah, I'm glad you're expanding it, because I was going to do the same thing, because I think that principle of what data to use to build the models is so critically important. And there are obviously limitations with any model that we build. Now, just philosophically, I'm in the camp that says the math is not biased. So some people are concerned about bias in models, and I say it's not the math, it's not the algorithms that are biased, that's the data that's biased. And the algorithms will spit out whatever data you feed it. That's what its ground truth is. And all of these algorithms, and this is something you mentioned too that I completely resonate with, is these algorithms are naive. They trust everything you said. They think everything is true, unless there are ways you can do this with modeling data to give kind of a confidence or a weighting associated with the record to say how much I believe this, or what happens mathematically is how much influence should this record have in building the model. So you can get fractional weights if it's a low source. Most people don't do that. Most people just say, here's a bunch of data, away we go. So there is going to be bias undoubtedly in every data set we bring to the picture. It's important to understand what that bias might be. And sometimes the bias is a good thing because we're trying to make specific decisions. So for example, if I'm in retail and I'm trying to predict who is going to, like, what's the likelihood someone's going to purchase something on the website in the next week? So what should that set of data be that I use to build the models from? Now, you could say, I only want to know that answer for people who have bought something in the past. Okay, so that's fine. So that's a subset. That's a bias sample. And of course, they're more likely to buy something again. But of course, if that model gets applied to the broad population, we have no guarantee that it's going to do well. I mean, it might by chance or by happenstance, or it may be that the patterns of behavior are the same between people who've bought something in the past and those who haven't, but probably not. But that's a decision we make as a business of what pool, what population we're trying to make the decision for. So you design the data based upon what you're trying to decide on. And we do this as humans kind of naturally. Like we'll, if we're trying to make a decision, let's say you're making a hiring decision, and you want to know, okay, I need somebody for this position. Well, who are you looking for? Well, I want somebody who is like this senior data science position, someone who knows the algorithms really well. So they've got a master's or a PhD, but they know retail really well. So they've got like 15 years of experience, and they're experts in Python, they're experts in R, and you come up with all these lists. Of course, there's nobody that matches all these, right? And that's the way a lot of these recs are created. But what do we do as people? When we're looking at this, we trade off how important each of these are when we're looking at this data coming in. And the algorithms don't know how to do that. They treat everything equally. So how do we achieve that? If we have a sense that, okay, all these things are true, but we really want to bias our pool more toward understanding the algorithms, and they can learn the retail part on the fly. So that means, well, it's good that they have that, but that's not critical. So what does that mean for the data? That means when we're bringing in data, we want the data to reflect those kinds of patterns so that the decisions that come out are reflecting our biases. So sometimes we don't want bias, sometimes we do, and we've got to build the data to reflect what decision we're trying to make and what subpopulations are more important to us in the process of making those decisions.
Yeah, well, I think what's interesting about that is that the kinds of bias we introduce into these models may not be obvious from the outset. So building a model predicting what you might buy on a website or in a retail location, the idea of using purchases of the past seems quite logical, right? I mean, like, what other data do you have? That's the data you have. So you use it, but recognizing that introduces a bias of that the kinds of people who shopped with you in the past. So for example, if you were trying to address a new market segment that you'd historically never sold to, using data from the past about the segment that you have, you've acknowledged that you're not successful at selling into that segment previously, and you're trying to address that segment.
Yes.
You know, the model could be not only not helpful, it could actually be harmful. It could actually set you up for failure.
Absolutely. And it's such a tricky thing. You know, a lot of times when I speak with execs and all, there's a view that we've got a whole pile of data, we'll throw it at you and magic will happen, because machine learning is basically, it's magic. Well, I don't know how it works, but it's just good things happen. Well,
Let's just say because machine learning.
That's right. Exactly. So to pick up your example of like with a new product, there's a concept in time series modeling in particular called stationarity. And so what we want to know is how consistent are these patterns of behavior over time? And the more stationary these are, the further back we can go without breaking the patterns. But you were mentioning with new products, it may be that there's a problem if we go back too far in time with the new product, because maybe it could be the business changed fundamentally. The demographic of who's buying has changed in the last 3 or 5 years. So, and sometimes that's very difficult to identify upfront. We don't really know where this is breaking. So usually my rule of thumb is I like to keep the time period backward in time for these kinds of models, whether it's IRS models looking at, because sometimes there's regulatory constraints that have changed over time. Like the tax law has changed in the last 10 years. We can't look at patterns of non-compliance 10 years ago and it necessarily applies now because things change so much. So I want as short of a time period as possible so that I have the most stationary amount of data. But then you've got a conundrum, right? The shorter you make the time period, yeah, that's more relevant to what you're going to be predicting in the near future, but there's less of it. And so how do you trade that off? Have enough data so you get stable patterns, but you don't go back too far in time so that you break patterns. Now, there's ways you can handle that, and I'm not going to go into that here. I'm happy to go through. In fact, if there's a part 2 ever, I could talk about those kinds of strategies because they rely on statistical tests and things like that. But you can get at that kind of a design of experiments approach to how you build your data. But you have to think about it. You don't need a PhD in statistics to do this either. You just have to have some common sense and probably some experience with where these models fail to be able to get there.
And so speaking of experience, and you brought up the IRS and the Navy SEALs, and you're certainly welcome to pick either of those examples, but I'm just trying to decide whether it's better to ask you about spectacular failures or spectacular successes, since both are fun. But maybe share a practical example of how you've seen this work applied.
Yeah, there's lots of, probably one of the more successful stories. I'm trying to think of pulling from 2 or 3, but let me mention one first, and if there's time, I'll mention the second one. One of the most surprising successes was I was building models for the Defense Finance and Accounting Service, which are the government accountants. And I think this gets at a real core business question about what algorithms you pick and what data you use and how you decide what's good or not. So the problem here is this: people submit invoices to the government, and some of them need to be investigated because people are people, and they try to defraud the government. Surprise, surprise. And so like they'll submit an invoice that's completely bogus, or they'll submit a duplicate invoice on a contract that's a valid contract, but you've already paid it out and they're hoping it gets through the system, or there's a bunch of different ways that this fraud occurs. One of the things that was interesting is we're interviewing the stakeholders was that there were, they have only so many investigators. So each month they may get, and I'm making the number up, but like 1 million invoices coming in. But they could only investigate 100. So what does that mean? Each month they can investigate 100. So what does that mean from a machine learning perspective? That means when we're building a model, first of all, we want models that do really well at the tail. You can imagine in your head a normal distribution or something like that. Just the tail, that's the only place that really matters. The rest of it, we're not going to investigate. So you can think of it this way. The model does not have to be accurate at all. It could be a coin flip almost everywhere, as long as at the very tip of that distribution, it does really well. That does inform what kinds of algorithms you might build. There's some algorithms that are great across all records. On average, it does a better job. And there's some that are better at finding small, homogeneous subsets of behavior that is interesting. And so that did drive us toward particular kinds of algorithms. Secondly, it drove us toward what metric we use to decide which model or models to pick. Because in this case, I would never use, and I almost never use things like percent correct classification or average error, something like that, with any of my clients. Because what was interesting to them, we want to maximize the effectiveness of the models in that top 100, period. So we picked the models that did the best job at that small subset, regardless of what the rock area in the curve was, regardless of what, whatever classic metric, precision and recall or anything like that. We didn't care. And so that was really successful because that gave them a better list to give to their workforce to investigate. So that drives data. And there are different data issues we had to consider too, because most of the cases were not labeled. Most of the cases, they didn't know if it's fraud or not. They didn't investigate it. But that means if we assume that there's some low level of fraud, we don't want too many of the unlabeled cases in our modeling data. Because the more there are, the more likely it is that there's something we're calling not fraud in some way or suspicious, the more that will leak into our model. So we want to have all of the fraud cases and a smaller subset of the non-fraud cases to build the model more effectively. So that's a bias we introduce into the data to avoid a potential problem with the labeling of the data. Boy, I just blurted out like a ton of stuff all at once, but that I thought was a helpful project to get at. There's a myriad of issues that we have to do as machine learning engineers or professionals to solve the problem, because we want it to be effective for the business, regardless of how fun it is to build.
Of course, and I think it speaks to this broader point, which is those things have changed a lot over time. So you do them very differently today than you might have done them in the past. And you're thinking a lot about what data is being brought into the process, what algorithms you're selecting. And it's not just as simple as sort of, building a neural net and saying that must be the answer because we forgot what the question was. Right. So maybe I'm going to go in a completely different direction for a second to sort of wrap up a little bit. You've had a long and illustrious career in this space. And I think you've pointed out very well that the space today algorithmically looks very similar to what it looked like 20 years ago, but there's some important differences in terms of how much compute is available and how we sort of approach problems. But what advice would you give to somebody who was just graduating their undergraduate today? They saw ChatGPT, they think that's super interesting. I should be doing something with that. Mm-hmm. And let's make it a little easier that they have some basic stats and math interest and/or skills. They're not just a humanities major. What career advice would you give them?
It's a really good question, because the buzz is around things like ChatGPT and deep learning, but the vast majority, and when I say vast, I mean like 99% of the problems out there to be solved are much simpler and much smaller, but very important. I've got a colleague, friend named James Taylor, who has this great picture about making business decisions, and he says there are big strategic decisions. There's the big ones that require the complex models and things, and that's kind of the deep learning mindset of thinking, especially around image processing or language networks. But then there are all these simpler, smaller problems, but there are so many of them that in aggregate, they probably will generate more revenue or make your company more efficient than nailing these big strategic ones. And so I would say for the graduating undergrad or grad student, to number one, don't be afraid of working with a company that is not data-driven yet, but wants to be data-driven, because there are so many problems to solve that to me, from a data perspective, almost all of them are interesting. So there are so many problems to solve out there. There's a lot of work out there that you can make use of these algorithms in an effective way. If you're really just interested in the deep learning side, that's a more competitive and narrower niche of the space. But if you're interested in data more generally, then there's plenty of work out there. But also, when you get into that company, one thing I recommend people, your job when you come in there is to make your boss and your boss's boss look good, and to make them look good and smart by what you do. So learn the craft, learn how to build the models well, but also learn how to understand what they want. And what they want is not necessarily what they say, because decision makers in analytics were getting better, but at the project manager level or the director level, the VP level, a lot of these individuals still don't have the language of data down yet. They don't know what machine learning can do, what it can't do. So you have to be a good listener to pick out those things that they're trying to accomplish and translate that into an analytics approach. I strongly recommend with all of these situations that we have lots of feedback loops, and every step of like weekly or bi-weekly at least, go to your boss and say, this is what I'm seeing in the data. Does this make sense? Because again, the data-driven approach is great. These algorithms are fantastic, but they have no common sense. And the data bias issues are really hard to tease out until you see what the models actually do. So those are two things I definitely recommend for folks. And learn that well, become proficient, and learn how to apply the models in the context of the business. Get good at that before you venture on your own. I mean, it'll take several years before, even with our modern cycles, that people want to become an independent consultant in the first year. It takes a while to be able to learn the things you need to learn. I've got a talk track, 5 things they didn't teach in grad school about learning. And it's these kinds of things. It's not a negative to them. They teach what they can. But there are things that you learn about the art of this field that you just have to experience it in order to understand.
And I think that's really good advice. Sort of get in. There's plenty of problems to be solved, and go follow the problems that are interesting and motivational to you, and dig in deeply and learn how to solve those problems. I like to become good at the craft, and it ultimately, like anything, it is a craft.
And toward that end, remember you're interviewing the company as well, and make sure that the person who is your direct report is somebody who you respect, and will serve you well as well. Because I've heard that a lot. People, it's a good story, it's a good company, but the person they're reporting to is just terrible, and they have to leave because it's such a bad situation. It's too political or something. And I know it's hard to tease out, but keep that in mind with that person you're reporting
Yeah,
to.
especially for one of those first jobs, since I did ask about somebody who's graduating undergrad, as those first jobs, those people that you work with are ultimately some of your biggest advocates over could be many, many years.
Yes, exactly.
Well, Dean, thank you so much for the time and the insights. It's been a pleasure to have you on DataMasters, and we'll look forward to chatting again soon.
Thank you very much, Anthony. Really enjoyed it.
DataMasters is brought to you by Tamr, the leader in data products. Visit tamr.com to learn how Tamr helps data teams quickly improve the quality and accuracy of their customer and company data. Be sure to click subscribe so you don't miss any future episodes. On behalf of the team here at Tamr, thanks for listening.